Hello, Regis students. So for the lab on recursion, it is a little bit chewy. But so I think what I'll do is I'll cut out the 10.2.4. I'm trying not to have you be totally swamped as you're learning all these ideas. So what we're going to do is we're going to use a library scikit-learn and use the object count vectorizer so you can experience some real recursion. And you're being given, the functions to do this. So your job is still to be assessing this. This is really the last class, and then I'll be having you do some exercises where you'll be doing a lot more thinking exercises. So, but these constructs, in order to play with them, you got to see them in action. It really is one of the best ways, so I hope that you're going to find that to be the same. So there's two components, and the first is using, essentially there's going to be text blocks, and I'm going to have you vectorize things. That means you're going to get the keyword tokens, and then you're going to go search for words. And then in the second one is really cool because it really shows you how the stacks work. They give you some nice visuals and some nice run times. And that way there you can actually see the trees build and the depth increase. So let me expand open the section here. And so when you get in here and you're looking at all these words, I try to make the outcome that you can see the entire outcome, and then you can see the vector and search for the words. So you need to run these in sequence. You have to run this one first, and then you're going to go down and run 10.1.2 to then go and search for the terms. And the search index that I have written here it's very simple, it's very powerful, it can be applied to big chunks of data, and I hope that you'll come to realize that at some point when you need it. But where we're starting from doing, we might be looking at a stem. REC is a stem, and they were able to find recursion, search, stem, so search and searching, or it could be learned. And so the thing to understand with recursion is that with the processing speed we have now, you can be going over millions of records, and so that's why, again, this is valuable. So what I'm asking for you to do is do your thoughtful analysis. So how does it feel similar to looping? Tell me, kind of wrapping up what you've put together across, all of these exercises and some smart answers. And then the second one here was stack-based search and timing. It actually, I'm able to show, it's to end with showing you how fast or the timing that happens. So again, you're going to need to run them all in order. And you're going to have root, child, and branching. Root, child, branching, and depth. These are all, the keywords that need to get into your repertoire for essential compute. So, along with trees and nesting. So we're going to be nesting some data. We're going to be putting it in trees, and then we're going to practice recursion to go down in the stacks to go and get it. This code is definitely chewy, all right? So don't, I'm not expecting, as soon as we're getting into for-i and range and branching and, where is the branch coming from? I understand it's getting more complex, okay? But what you need to be able to visualize is I need you to be able to see, we're able to use a dictionary object so we could represent the tree that was built to go find the children and the children's value. And these are very common ways that data is stored, that people are, taking your information off YouTube. It's how they're building their search parameters of what you're watching. So, there's a lot of other things I'm not telling you here. But when we get into this depth of frame, the depth first search, you're going as far as you can down a branch. And so I'm hoping that, this is not going to get too far off the list. Like over your head. But I kind of bring it back in 10.3 that, hey, I'm going to get into a stack and I'm going to use last in, first out in order to search what's going on in the stack to find a value. So, and then the last exercise is with time, and it's comparing the milliseconds of what, one was, almost 50% faster, right? So this is the baseline reason of why so the baseline conclusion, like why we do recursion. So thank you so much for your time, and I look forward to meeting you at some point. Okay, bye.